So for our second worksheet, which is basic limit techniques, the first question we are given a limit which is approaching 0, and we're asked to create a table to guess the limit of the following expression. So on the top part of our table, we start in the middle with 0, and on the left side we get negative values that are getting closer and closer to 0. As you can see, the closest 0.001. Then on the right side we have numbers that are getting closer and closer to 0 from the positive side. And you can use your graphing calculator and plug those in to get our numbers on the bottom. And as you can see, the numbers on the bottom will get closer and closer to a number. And so if on the left side we have 1.99 and the right side we have 2.001, you can assume that it's getting closer and closer to the number 2. So by plugging in 0, the limit as x approaches 0 is equaling to 2. The second question is asking us to use the piecewise function and graph it. So we have f of x equals square root of x, and we know that that graph at 1, it will always be 1, and then at 4, it'll be 2 because it's an exponential graph, and that is saying that it's an exponential graph when x is less than 4. So we go to the x-axis, we find 4, and we know that anything less than it, so 3, 2, negative, whatever, is going to be the exponent graph, just like this. Then we know that it is also a bubble, not a filled-in point, because it is a less than symbol. The only way it is a filled-in bubble is if it is an equal. We then have f of x equals 3, so that means if x is at 4, we can go up to 3, and that is a filled-in bubble because it is equal. Then we have, if x is greater than 4, we have x plus 1. So we can take this 4, plug it into x plus 1, we get 5. So at 4 on the x-axis, we go up to 5. Again, it's not equal, so we make a full circle. And then knowing that our function is x plus 1, then we can always just go up 1 over 1, up 1 over 1 to create the rest of our graph. At the bottom here, we have our limit as x approaches 0 from the positive side. So that means from the positive side on the x-axis, we're approaching 0. We can see that with our graph, 0 equals 0. So our answer to that is 0. And then we have a limit of f of x as it approaches 4 from the negative side. So we're approaching from the negative side of our graph as it approaches 4. And that gets us 2. And because right there. And then we have our limit of f of x as x approaches from the positive side towards 4. So we're approaching 4 from the positive side, and our graph is coming into 5, which is how we get 5 as our answer. Then we have limit f of x equals 3, and because it's not approaching it from a positive or negative side, we can know that it is our exact point where x equals 4 and f of x equals 3. Then we have our limit as x approaches 1, and again, it's not from the positive or negative side, so we can just see x at 1 is 1, knowing that it is a square root f of x equals square root of x graph. Then on the back side, we're given f of x equals x plus 5 over x squared plus 7x plus 10. And with this, we need to make sure to take the denominator of our function and factor it, because if we didn't, we would get 0 over 0, which is an indeterminate form. So by factoring it, we get x plus 2 and x plus 5, which gives us the function f of x as x approaches negative 5 equals x plus 5 over 2x parentheses and then x plus 5, which simplifies to 1 over 2x. Plugging in the 5, we get our limit of f of x as x approaches negative 5 as 1 over negative 3. Then the next question asks us, is there a hole or an asymptote at x equals negative 5? And we know that it's a hole because when we cancel out from the top to bottom, it is taken out of our function, and so we know that it's a hole.